Practice problems for lesson 24. Question 1. Two inequalities are graphed on the same coordinate plane. Which region represents the solution to the system of the two inequalities? Well, this one is going to be where the two overlap. And so that's going to be in region D there. So region D. Question 2. Select all the pairs of x and y that are solutions to the system of inequalities. Y is less than or equal to negative 2x plus 6, and x minus y is less than 6. So on this one, I'm just going to show one of these, how you would do it, and then I will give you the answers. So let's say I wanted to check A. So I would substitute 0 in for these. So in question, the first equation, that'll be my first equation, that'll be the second one. That first equation is going to become 0, because I'm plugging that in for y, is less than or equal to negative 2 times 0 plus 6, which is 0 is less than or equal to 6. That works. And does it work for the second one? For my second equation, I'm plugging 0 in for x and y. 0 minus 0 is less than 6. Well, that works. 0 is less than 6. So that tells me that A is going to be a solution. If you did the same thing, B would not work, C would not work, D does work, E does not. So A and D are the two that work, and you'd figure that out by substitution. Question 3. Jada has $200 to spend on flowers for a school celebration. She decides that only flowers that she wants to buy are roses and carnations. Roses cost $1.45 each, and carnations cost 65 cents each. Jada buys enough roses so that each of the 75 people attending the event can take home at least one rose. So first I need to write an inequality to represent the constraints that every person takes home at least one rose. So for this one, that is going to be, we know there's 75 people, and we want to give each one a rose. So that means that the number of roses, which I'll use for R, needs to be greater than or equal to 75, which is the number of people. And then the other constraint is the money. We only have $200 to spend, so I'm going to put it needs to be less than or equal to 200. And to figure out the cost, it's $1.45 per one rose, which you're told up here, and it's 65 cents for each carnation. So when I add those together, it needs to be less than or equal to 200. Question 4. Here are the graphs of the equations 3x plus y equals 9 and 3x minus y equals 9 on the same coordinate plane. Label each graph with the equation that it represents. So on these ones, how would you figure that out? Different ways to do it. I'm looking if there's any whole points. I'm going to take, let's just take the second one. And actually the first one, I think it's going to be easier. Put it into slope-intercept form. So if I took 3x away from both sides, I'm going to end up with y equals negative 3x plus 9. That is going to be that has a negative slope, so that is my blue line. So this one is going to be 3x plus y equals 9, which means the other one needs to be 3x minus y equals 9. Identify the region that represents the solution to 3x plus y is less than 9. So 3x plus y is less than 9. So I'm looking at this one, but I'm changing that equals to an inequality. So I need to figure out which region am I going to shade? And is the boundary line part of the solution? So first of all, the boundary line is not going to be part of the solution because I don't want the left side of this. I don't want 3x plus y to actually equal 9. So the way I would show that is graphically. I would make this a dashed line. And then to figure out which side to shade, pick a point. Always like to use 0, 0. Is 0, 0 a solution? So if I plug 0, 0 in for that, for x and y, I'm going to end up with 0 is less than 9, which is a true statement. So that means I would be shading everything on this side of that boundary line. Part C. Identify the region that represents 3x minus y is less than 9. Is the boundary line part of the solution? And also shade the region. So now I'm using this other line, but I'm doing 3x minus y is less than 9. Same thing. I don't want it to equal 9, so I'm not going to include the boundary line. So we'll go ahead and make this also a dashed line. And I need to figure out which one, which side am I going to shade? Well, if I put 0, 0 into this, okay, I'm going to end up with 0 is less than 9. And so 0, 0 is a solution. And so that means I'm going to shade everything to the right of that line. We'll do this in red to make it different. So it's going to be everything over here. All right, and then identify a point that is a solution to both of those. That's where I've shaded it twice. So let's do that in blacks. I shaded it twice over here. So anything in that region is going to work. I'm going to go ahead and pick a point. Oh, I've already got one right there at 0, 0. That's true for both of them. So that could be a possible answer for D. But really anything in that dark shaded region would work. Question 5, which coordinate pair is a solution to 4x minus 2y is less than 22? So on this one, I would be substituting each of those values into it. And I know that the solution for this one is going to be B. And I'm just going to show you why that one works. If I put in 4 for x, so that's going to be 4 times 4, and 3 for y. And I want to see, is that less than 22? 16 minus 6, which is 10. 10 is less than 22, so it works. I'm not going to go through and plug all of the other ones in, but let me do just part A to show you. So if I put A into that, it's going to be 4 times 4 minus 2 times negative 3. That's 16 plus 6, which is 22. That doesn't work because 22 is not less than 22. So you see, like, this one worked, this one didn't, which is why B is a solution and A is not. And if you tried C and D, those wouldn't work either. Question 6, consider the line given. The pair 3, 5 is a solution to the equation. Find another pair that is. Okay, so that's just saying if I plug 3 and 5 in there, it's going to work. There's an infinite number of possible answers. I'm going to go ahead and go with 0 and negative 4. I did that one because I knew if I plug 0 into that first part, that term is just going to go away. And then I just need to think, well, what y value would make that true? Which in this case is negative 4. So that's one possible answer, but there is an infinite number of choices. Part B, are 3, 5, and 2, negative 10 solutions to the inequality? Explain how you know. Well, we could go ahead. We don't have a graph here, so I'm going to plug them in. If I plug 3, 5, we know 3, 5 is a solution to this one. So that means if I plug 3, 5 into the inequality over here, it's going to give me 12 also, and 12 is less than 12. So this first one is going to be a solution. The second one, 2, negative 10, I'm going to need to go through and do a little bit of math to check that. So plug in 2 for x, negative 10 for y. 9 times 2 minus 3 times negative 10. That's going to be 18 plus 30, which is 48. That is not less than 12, so this one is not a solution. So if I was going to say explain how you know, I would say I substituted each ordered pair into the inequality to see if it worked, or something like that. It doesn't have to be exactly in that phrase, but something like that. Question 7, Elena is considered buying bracelets and necklaces as gifts for her friends. Bracelets cost $3 and necklaces cost $5. She can spend no more than $30 on the gifts. Write an inequality to represent this situation. Well, that's going to be 3b, because each bracelet costs $3 plus 5n for each necklace, and we need to keep that no more than $30, so that needs to be less than or equal to 30. Graph that solution. This looks like it's going to be a nice easy one to find the intercepts for, so I'm going to figure out when the bracelets are 0, the necklaces need to be 6, so that is going to be right there. And when the necklaces are 0, the bracelets need to be 10, so that's right there. Connect the points. And then decide which side am I going to shade. Well, 0, 0 is a solution. It makes it work. And so I'm going to shade the side of the graph that's got 0, 0 on it. And you notice I'm actually stopping at on the axes because negative numbers wouldn't make sense in this problem. 7C, explain how we could check if the boundary is included or excluded. We could substitute if we wanted to, pick a point that's on that line and substitute it in. And so let's say I pick, right here. I'm going to choose, what is that, 5, 3? And see, does it work when I plug it into this? Well, that's going to give me 3 times 5 plus 5 times 3. Is that less than or equal to 30? Well, it's going to give me 30. And 30 is less than or equal to 30. So that tells me that it's going to be a solution. All right, question 8. In physical education class, Mai takes 10 free throws and 10 jump shots. She earns 1 point for each free throw she makes and 2 points for each jump shot she makes. The greatest number of points that she can earn is 30. Write an inequality to describe the constraints. Specify what each variable represents. So I'll use for the number of free throws, F, and for the number of jump shots, J. Okay, so if I was going to write the inequalities for this one, I know, first of all, that she takes 10 free throws and 10 jump shots. She earns 1 point for each free throw she makes. So if I take the number of free throws that she makes plus 2 times the number of jump shots that she makes, that tells me her number of points, but the greatest that she can earn is 30. So that means that needs to stay less than or equal to 30. Name one solution to this inequality. A bunch of possible answers. How about I just do 0, 0? She doesn't make any. That would work because, if she doesn't make any free throws or any jump shots, she's definitely going to score less than 30. But, there's a lot of different answers that you could give. I could do, let's say 5, 6 if I wanted to do something a little bit less obvious. So if I made 5 free throws and 6 jump shots, that's going to be 5 points plus 12 points, which is 17 points, which is less than 30. So a bunch of answers there that would work. Question 9. A rectangle with width W and length L has a perimeter greater than 100, and there is the graph for that situation. Write an inequality that represents this situation. Well, first of all, I need to figure out the length and on this one, it has a perimeter greater than 100. Remember, just a quick little geometry review. There's a rectangle, there's the width and the length. The perimeter is the distance away around the outside. So to find the perimeter, you add both, because there's a width over here, so you add both widths, both lengths, and that equals the perimeter, okay? Or a little simpler version of that is 2W plus 2L. Well, in this case, we know that the perimeter has to be greater than 100. So I could just tweak that a little bit and say the perimeter has to be greater than 2W plus 2L. Can the rectangle have a width of 45 and a length of 10? Well, I could substitute those values in, but why? I've already got the graph, right? So if it has a width of 45 and a length of 10, that's right here. 45, 10. That is in the shaded region, so that would be an acceptable solution. So I would say, can it? Yes. I'm going to say it is in the shaded region, thus a solution. Or you could plug it in and show that it works that way. Can the rectangle have a width of 30 and a length of 20? Well, let's see. A length of 30, a width of 20. That's right there. It's on the line. So this one would be a no. And the reason it's a no, it is on the boundary line, which is not part of the solution set. I would say probably what's not part of the solution set in this problem, because sometimes we do include those. On this one we don't, and you can tell that because of the dashed line. And you can also tell that because the inequality is a greater than and not just not a greater than or equal to.